So now let's focus on the normal stresses. Let's focus on element A first, okay? Let's do element A. Okay, let's do element A. Okay, let's consider our element A. So the first thing we're going to do, we are going to focus on the normal stresses. Okay, so the normal stresses formula is stress Z at point A will be equal to PZ over A plus or minus MX over IXX multiplied by Y plus or minus MY over IYY multiplied by X. Okay. So we will need the geometries, the information of this. Come on. Let me do this first. What we are aware of is element A. Okay, so this is where element A is. The distance of element A from the edge is 75 millimeters. Okay, this is 75 millimeters. So the first thing we do, so we're going to put in values. So PZ, and we know that PZ is going to induce compression. So minus 100 times 10 to the power 3. Cross-sectional area is over here. Okay. So it's 5310 times 10 to the power minus 6. Because over here, the area is in what? In millimeters, and we have to do it in meters. Okay. So the next thing is mx. Okay, so we look at our mx value. Our mx value is 22750. 22.750 times 10 to the power 3. Okay. And then we divide by IXX. So IXX is 40.9. You can see it's 40.9, yes or no? Is the words big enough? Are we okay? Right? So we can see over here, this is 40.9. Okay, so 40.9 times 10 to the power minus 6. And then we have to look at the y distance. Now, this is where a lot of mistakes has been made. So we know that over here, this direction is the y distance. This direction is the what? The x what? Distance. So the y distance is parallel to D, so it's equal to 0.25 divided by 2. Okay. So from here, moment about x at point A, could you all remember whether is it tensile or compression? I can't remember now. Okay, so you go over here, you look at moment about x, element A is in what? It's in tension. So now you put what? Plus. That is why I make all of you do the analysis what? Earlier. Are we clear? Okay, now you just need to focus on putting in what? Numbers. Right? Okay, then the next one, my. Yes, ma'am. The y value over here is 205 divided by 2 because D is 205 or 0.205. Okay. The next thing we look at is my. Okay, so my is what? 9600. Right? And then divide by IYY. IYY is 9.01. times 10 to the power minus 6. Now, you have to be real careful. This is x distance. Okay. So x distance is what? It's in the horizontal way. This is our x distance. So to find this distance over here, this is our x, right? So BF is equal to 0.166 divided by 2 minus by what? 75 times 10 to the power minus 3. 166 divided by 2, because BF is equal to 166. The best friend is equal to 0.166. Divided by 2, okay, at the centroid, minus 75 times 10 to the power 3. Makes sense or no? Okay, so for this case again, I could not remember what is my doing on element A. So if we go to the lecture, which I was so hyper about, we realize that my is inducing a what? Compression. Are we clear? And then you look at your diagram. Oh yeah, it's doing a compression. So now you know that this is a what? Minus sign. Okay, and then I mean this part is the what? Normal stress is usually the easy one. Yes or no? Okay. So this will be equal to 100 power 3 divided by 5310 power minus 6 is equal to minus 18.832 times 10 to the power 6 plus by 22.75 power 3 times by 205 divided by 2 to 40.9 power minus 6. 57.014 times 10 to the power 6. And then we have another minus 8.524 times 10 to power of 6. Okay, 9.01. Did I see the number wrong? Yep, it's 9.01. I don't know why. Okay, so from here, you get minus 18.832 power 6 plus by 57.014 power 6 minus 8.2524 power 6. And your answer is 29.658 positive 29.658 times 10 to the power 6 Pascal. Now this is the easy part, okay? Let me do it again. 29.658. Right. So what we have done, if we look at element A, if we were to focus on element A, we have just found out that due to all the loadings that we have, is under tension by 29.658 times 10 to the power 6 Pascal. There's a gentleman, a student asked, do we need to consider buckling for element A region? The answer is what? No, for element A. Are we clear? Because we are having what? Tension. Okay. Now, the next thing that we are going to look at, any questions so far? This part is pretty straightforward, yes or no? You just need to focus on your what? A lot of times students make mistake is this is the one that a lot of times students make mistake in terms of value. You have to be come on. You have to be crystal clear. What is your Y direction? What is your what? X direction in terms of what? Values. Are we clear? Okay, you have to be very, very clear on this. Okay, a lot of time we deduct mark is because of that, and also we will deduct mark because the direction has been done what? Wrongly. Okay, this is critical. Right, so the next thing that we're going to do, which is, it's not as straightforward as normal stress is what? Shearing stress. Okay, so I'm going to take my time. Okay, I'm going to go slow. No jokes. Okay, I want you to focus. Yeah, no jokes. Okay. Right. So this is our, and then, right. So we want to focus on Vx first. And we know that Vx is equal to 16 times 10 to the power 3 Newton, because we know that both are coming out this way. Okay. So we know at element A is over here. Okay. We construct the shear flow. Construct the shear flow. Okay. The region we're going to take. Okay. So all the 9 rules that you learned, you have to apply now. The region we're going to take, the area we're going to take, we're going to focus on is this area that I'm shading in black now. Can you see that? Okay. Why? Because over here is a terminal, down here is a terminal. The first moment of area cannot cross the centroid. Okay. Now, the difficult part is the first moment of area. Okay. So let's put in the formula first. So we know that the shear, okay, the shear, what direction? Don't know yet. Don't worry about that. Okay. Is equal to Vx over what? Iyy Qy divided by T. So we put on the values that we know first. Okay, we know that Vx is equal to what? 16 times 10 to the power of 3. Iyy, we look at the table, is 9.01 times 10 to the power minus 6. This is in Newton, this is meter to the power 4. And then the next thing is we look at the what? Thickness. Okay. So the thickness is what? Can someone tell me what is the thickness? TW or TF? Yeah, you're right. Okay, so TF is equal to what? TF is equal to 11.8 times 10 to the power minus 3 meter. Are we clear? You can take the wrong, you take TW, we are game over. It's TF because TF is this thickness of the what? Of the flange. So the next thing we have to do QY. What does QY means? QY means the first moment of area about the what? Y-axis. So the y-axis is the axis that is fixed. Okay. So this is your what? This is your y-axis. Okay. So now the next thing that we're going to do, okay, we know that Qy is equal to width times that multiplied by x bar. Why x bar? Because the perpendicular distance of the area is x bar is in this direction, because this is our x direction. That is our what? Y direction. Are we clear? This again, a lot of times students make what? Mistake. Okay. So again, the axis of interest is YY. This will be our width. Over here, this is our what? This is our depth. Did we learn anything new? We just put 10 questions into one question. Okay? That's why it's important to write proper summary sheet for this course. So the width is equal to what? The width is my TF. So TF is equal to 11.8 times 10 to the power minus 3, right? The depth, because the depth is given is 75 millimeters, the depth is 75 times 10 to the power minus 3. The X bar is now your BF divided by 2, 0.166 divided by 2 minus by 75 times 10 to the power minus 3 divided by 2. Why did we do that? Because the distance from here to here is equal to what? 0.166 divided by 2. And then we know that the distance from here to here is what? 75 times 10 to the power minus 3 divided by 2. Over here, this distance is your what? Is your X bar. Okay. So from here, you will get 0.166 divided by 2